This is the CBE1 test in 1060. You're going to need your trig formula sheet. So we're going to start with the unit circle. In the unit circle, the sine of theta is the y value, and the cosine of theta is the x value. So right here we have the sine of negative 7 pi over 6. So this angle here is 7 pi over 6. So negative 7 pi over 6 would be this angle, and it's just the y value, 1/2. Okay. The next one is the cosine of 5 pi over 3. So 5 pi over 3 is this angle. The cosine is just going to be 1/2. And then the last one, the tangent of 3 pi over 4. So tangent is opposite divided by adjacent. So that's going to be, well, let's do, if this is 3 pi over 4, here's my triangle. So tangent is going to be y over x. So root 2 over 2 divided by negative root 2 over 2 is just negative 1. If you end up with a tangent that says 1/2 over negative root 3 over 2, then we invert and multiply 2 over negative root 3. The 2's cancel, and I get negative 1 over root 3. Rationalizing the denominator, root 3 over 3, we get negative root 3 over 3. That would be the tangent. Okay. Okay. The secant of 6 pi. So where is 6 pi? Well, that would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. And the secant is 1 over the cosine. So this is the point 1 comma 0. The cosine of this is 1. So the secant is just 1 over 1, which is 1. If we wanted the cosecant, that would be 1 over the sine. And the sine in this case is 0. And 0 over 1 flipped upside down is 1 over 0. And it wants you to type in dne if there's no solution. Okay. Negative 5 pi over 2. So this is negative 1 over 2, negative 2 over 2, 3 over 2, or sorry, 3, 4, 5. So we're right here. And the cotangent is going to be the x divided by the y. So this point here is 0, negative 1. So that would be 0 over negative 1, which is just 0. Got it? Okay. All right. These are a little bit weird because technically there are an infinite number of answers. But the sine wave looks like this. And the sine wave is not one-to-one, meaning it fails the horizontal line test. So technically the sine wave is not invertible. So in order to make the sine wave invertible, we are going to only include this much of the graph. Everything from negative 90 up to 90. So when we invert the sine, we're only going to use this piece. And in the unit circle, that means that we're only going to invert the sine in quadrants 1 and 4. We could have chosen different quadrants if we wanted. And technically, the sine inverse of negative 1 has an infinite number of answers, but we are going to restrict ourselves to quadrants 1 and 4. So when you invert the sine, you just need to remember that. 1 and 4. The cosine graph is different. So the cosine graph looks like this. And when we invert the cosine, we only invert this piece, which is from 0 degrees to 180 degrees, which means in the unit circle, we only invert the cosine along quadrants 1 and 2. And you just sort of have to remember that. So this is 1 and 2. Okay? So the sine of an angle is going to spit out a ratio, and the particular ratio is O divided by H. So the sine inverse of O over H is the angle. So what angle gives us a ratio of 0 over 1? Well, sine is the y value, so it would be 0 radians. Does it want it in radians? Yeah. 0 radians. Okay. What if we had the sine inverse of negative 1/2? Well, if we look at our unit circle, where do we have a sine equal to negative 1/2? And we're only allowed to look in quadrants 1 and 4. So it would be 11 pi over 6. Does that make sense? Okay. What about the cosine inverse of 0? Well, cosine is only allowed to look in quadrants 1 and 2, and cosine is the x value, so that would be this angle, pi over 2. What about the cosine inverse of root 3 over 2? So that would be an x value that gives me root 3 over 2. That would be that angle. What about the cosine inverse of negative 1/2? We're only looking in quadrants 1 and 2. We need a cosine value, so the x is negative 1/2. This would be it, and the answer would be 2 pi over 3. Does that make sense? Now, technically, you could pick any angle where the x is negative 1/2, but the convention is sine is 1 and 4, and cosine is 1 and 2. Okay. So where is tangent equal to root 3 over 3? So root 3 over 3 is the same as 1 over root 3, which is the same as 1/2 over root 3 over 2. And tangent is y divided by x. So we need to find an angle where the y is 1/2 and the x is root 3 over 2. So if we look at the unit circle, so we want the y to be 1/2 and the x to be root 3 over 2. So the answer is pi over 6. Oh, this one's... Did I get that wrong? So root 3 over 3 is 1 over root 3, which is 1/2 divided by root 3 over 2. And tangent is sine over cosine, so y over x. So y is 1/2. Yeah, that's wrong. Hopefully that's not the case on the actual test, but that's wrong. That should be pi over 6. What's that? No, so inverse tangent doesn't mean 1 over tangent. So we used to call it arctan, but arctan doesn't fit on your calculators. So this makes it look like it's a reciprocal, but it's not, which is really confusing. So the reciprocal would be cotangent, and that would be x over y. Does that make sense? So watch this. Let's do it in degrees because it's going to make a little bit more sense. So that's 30 degrees. So if I type in the tangent of 30, I get 0.577, which is the square root, the square root of 3 divided by 3. So it should be 30 degrees, but they have it as pi over 3, which is wrong. So let's the practice questions are a little bit different than the test questions. So if you run into that, let me know. Okay. And actually, I know there was a mistake somewhere on this test. I got an email from the professor and he went in and fixed it, but I don't think he fixed it on the practice. I think they fixed it on the actual test. So this might be the problem that they were talking about. Okay. So what's going on here? Well, this wants to spit out an angle. So here is my ratio. So I need to build a triangle where this angle is theta, and the ratio is 1 over 3. So the O divided by the H is 1/3. 1 for the O, 3 for the H. Got that? Now, I don't know how big theta is, and it turns out I don't care. Because I want to take the sine, and this right here is angle theta. Well, what is the sine of theta? It's 1 over 3. So essentially, these cancel. They're inverses of each other. And the answer is 1/3. And you say, oh, great, that's nice. So let's just cancel these. Well, it's not that simple. So where is this angle? It's in quadrant 4. So if I draw a rotation of negative pi over 6, I land in quadrant 4. Okay. So what is the cosine of negative pi over 6? Well, my y value, my x value is is root 3 over 2, and my y value is negative 1/2. Okay, and the angle is negative pi over 6. Okay, and that draws a triangle. So now I take this triangle and I remove it from the coordinate plane, right? So this angle is now pi over 6. Right? So this is still root 3 over 2, comma, negative 1/2. So this tells me where to draw the triangle, and then I want the cosine inverse of that triangle, but I have removed it from the coordinate plane, and so that angle is now pi over 6. Because negative angles only exist in the coordinate plane. Does that make sense? Okay. So you want to cancel these and say negative pi over 6, but it's actually just going to be pi over 6. I've got another version of the test loaded. Let's check and see what this one gives us. Okay. So these cancel nicely, and the answer is 3 over 4. This one wants me to draw an angle in quadrant 4. Okay. This is the rotation. And what triangle does that rotation build? It builds this triangle. Okay, and how big is that angle? It's going to be pi over 4. Okay, that was number 4. Number 5. Okay, these are a little bit harder. So the secant of theta is h over a. You get that? So the secant inverse of theta, the secant inverse of h over a is theta. Okay? So that means that 5x is h over a. And to make it easier, I'm going to do that. So the secant inverse of 5x over 1 is equal to theta, which means 5x is my hypotenuse and 1 is my adjacent. That will allow me to draw a triangle. So I draw a triangle. We call this angle theta. We put 5x for my h and 1 for my a. And then we just do the Pythagorean theorem to finish that triangle. So 5x squared plus, not plus, equals 1 squared. Okay, let's call this my opposite side. So 1 squared plus opposite squared is equal to 5x squared. All right? So I'm going to subtract 1 and then take the square root. And technically, it should be plus or minus the square root, but these side lengths are going to be positive, so we don't need to worry about that. So this side over here is the square root of 25x squared minus 1. Do both of you understand that? Okay. So now we go back to the original problem. This allowed me to build the triangle, and now I want the cosecant of that triangle. So cosecant of theta, not cosine, cosecant of theta is h over o. So I just go over here. H is 5x, and o is the square root of 25x squared minus 1. Okay, do you want to see another one of those? You load test 1. Okay. So tangent is O over A. I need to build a triangle where O is 3x and A is 1. So draw a triangle, label theta. So O is 3x and A is 1. So what is H? 1 squared plus 3x squared equals H squared. So H is the square root of 3x squared plus 1. Oh, 9. Thank you. 9x squared plus 1. So I replace h with 9x squared plus 1. And now I want the secant. Secant is h over a. So 9x squared plus 1 divided by 1 is just 9x squared plus 1. That make sense? Do you want to see another one? Okay, I'll just make one up. So let's do the cosine inverse of, I don't know, 4x, and I want to take the cotangent of that. So I draw a triangle. So 4x and 1, that's my cosine. So here's my theta. Now I need to figure out the O side. So 4x squared plus my opposite squared is equal to 1 squared. So we'll subtract 16x squared and then take the square root. So this is the square root of 1 minus 16x squared. And cotangent is going to be a divided by O. So that would be the a side of 4x divided by the O side is the square root of 1 minus 16x squared. And every problem I've seen, they don't rationalize the denominator. It will let you leave it in that form, which is nice. You don't want to rationalize the denominator. Okay, good? Okay, so we know two things. The tangent is negative 1 over 5, and the sine is positive. Remember, in the unit circle, the sine is the y value. So where is the sign positive? That would be quadrant 1 and quadrant 2. So I am somewhere in quadrant 1 and quadrant 2. And I know that my O divided by A is negative 1. Let's do it this way. 1/5 with a negative out front. So I cannot be in quadrant 1. There are no negatives in quadrant 1. So I must be in quadrant 2. Okay? My O side is a 1, and my A side is a 5, and one of them has to be negative. Well, it's going to be the 5. I don't have a choice. Okay? And don't forget, H is always positive because I'm in quadrant 2. So the X's are negative in quadrant 2. So this will help me narrow down which quadrants I could be in, and then this will help me figure out which of those 2 quadrants I am in, and then you just label the triangle, and then you label the negative accordingly. Now, if we happen to be in quadrant 3, they're both going to be negative, and the tangent would be positive. So sometimes it's a little bit tricky. You might have a positive number because there are 2 negatives in the problem. Okay? All right, so we know where we are. So what is the cosine of that angle? So this is my angle, right? The cosine is just going to be negative 5 over h. So h squared equals 1 squared plus 5 squared. So h squared equals 26. So this is the square root of 26. What is the cosine? Negative 5 over the square root of 26. And they did not make you rationalize that denominator. Okay. What is the cosecant? Cosecant is h over o. So that would be root 26 divided by 1. Can you handle those? Okay. If you are looking horizontal and you rotate up, that is called the angle of elevation. If you are looking horizontal and you rotate down, that is called the angle of depression. Okay, so we have an airplane that is 3850 meters high. And we have a tower with an angle of elevation of 65. What is the distance between the plane and the control tower? So that would be this. This is just simple right triangle trig. The sine of 3850 is equal, the sine of 65 is equal to 3850 divided by x. So we cross multiply. 3850 equals x sine 65. We divide by the sine of 65. So 3850 divided by the sine of 65. 4248. Okay. Hopefully you remember those. That's from years and years ago. All right, these are tricky. Okay. When you graph the sine function, this number determines whether you slide up or down. This number determines your vertical stretch or compression. So whether we stretch it vertically or shrink it vertically. This number is our left or right movement, but not really. It's more complicated than that. And this is our horizontal compression or stretch. Okay? So, in order to figure out what the horizontal shift is, well, let's do this first. Okay, so here is my sine graph. It goes from 1 to -1, and the period is 2 pi. That's my sine graph. Cosine graph also has a period of 2 pi, but it looks like this, from 1 to -1, and it goes out to 2 pi. Okay? The period of any transformed sine graph is, so period equals 2 pi divided by a. And this number here is a. Okay? So, the period is 2 pi divided by pi, which is 2. So this sine function is going to cycle every 2 spaces. It will go through a full cycle every 2 spaces. So if I were to draw that, it would look like this. Okay? But it has been shifted all over the place. Okay? We know we have a horizontal translation to the right because we are subtracting inside. However, the horizontal translation is not 2 pi, and this is the hard part. What we need to do to figure out the horizontal translation is pull out a pi. So 5 sine of pi times x minus 2, and then minus 3. Okay? So the horizontal translation is right 2. What's going to happen when I shift this to the right 2? It's going to land in exactly the same spot, right? So it looks like this. If I shift the black one to the right 2, it's going to land exactly where the blue one landed, which is nice. Okay? So we don't need to worry about a horizontal shift. Okay? What is this going to do? That's going to make it 5 times taller. So now instead of going from -1 to 1, it's going to go from 5 to -5. Okay? And then what does the -3 do? Brings it down 3. So this goes down 3, this goes down 3, this one goes down 3, and anyway, so that's where we get that graph. Okay, how does it want you to graph this? These are always a little bit weird. Okay, so click a point on the graph that corresponds to the vertical center. So I'm going to pick, this is my vertical center. And then click a point corresponding to the first maximum or minimum point of the wave that occurs to the right of the first point you clicked. So from here, what is the first maximum? Right there. And if you click those 2 points, then it will draw a sine curve for you. Okay, let's switch over to the other test. Okay. So -2 sine of, I'm going to pull out an pi over 4, and this is the tricky part. What goes there? Well, let's call that number h. H is equal to what? So I'm going to pull a pi over 4 out of that and pull a pi over 4 out of that. So pi over 4 times h is equal to pi. You see that? So we divide by pi over 4, so we invert and multiply. So h is 4. Okay, now let's look at that just so we understand. Pi over 4 x plus 4. Is pi over 4 times 4 equal to pi? Yes. So we pulled the pi out, and then that left me with a 1, and I'm going to pull out a 4th. How many 1/4ths are there in 1? 4 of them. Okay. So my period is 2 pi divided by my a term, pi over 4. So invert multiply, 2 pi over 1 times 4 over pi. My pi's cancel, and my period is 8. So that means I do a full cycle from here to here. So 4 would be my half cycle, and 2 would be my quarter cycle. So this is my graph. Does that make sense? All right. Now, what will this do? It's going to shift it to the left 4. So we're going to go here, 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 and here. Okay. So I took care of this, and I took care of that. What is the -2 going to do? It's going to flip it upside down and double its height. So now it will go here, 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 or double its height, not quadruple, sorry. That is now my curve. And then take all those points and drop them down 3. So this one goes there, 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 there. Oh, nope, I'm wrong. There. Okay. So I need to pick a center line point. So here's my center line point. And then I select whatever the next peak or trough is. So what point is either the highest or the lowest right after that? So I would click on that point. Can you handle those? Okay. Okay, cosine graph. My cosine graph starts at 1, has a period of 2 pi. My a term is 3/4. So the period of this is 2 pi over 3/4. That turns into 2 pi over 1 times 4/3. And that gives me 8 pi over 3. So my period is 8 pi over 3. Okay. Direction of the phase shift. Are we going left or are we going right? So phase just means, well, phase is your x-axis numbers. So we're going to phase shift left. The magnitude of the phase shift. Well, I need to pull out this 3/4. So the cosine of 3/4 times x plus something. What is that something? Well, I started with a pi, and I pulled out a 3/4. What's left? Well, if I call this number h, 3/4 times h is pi. So I divide by 3/4 and I get 4/3. So my h is 4 pi over 3. So this here is 4 pi over 3. So I moved left 4 pi over 3. So 4 pi over 3. Okay, now for the hard part. This is the dumbest question. This says, how many peaks are there from -2 pi to 2 pi? So here is -2 pi, and here is 2 pi. How many peaks are there? Well, where am I starting? I am starting left 4 pi over 3. So if this is -pi, and this is pi, -4 pi over 3 is right here. And the cosine starts up at 1. Does that make sense? Okay. And my period is 8 pi over 3. So I count over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do a full cycle in that amount of time. do I have enough room to make another peak? So I would need to count over 1, 2, 3, 4, 5, 6, 7, 8 before I reached another peak. Not enough room. If I was here, 1, 2, 3, 4, 5, 6, 7, 8. So how many peaks are there between this line and this line? There are only 2. Okay, let's open up the other test. I don't know which one I was on. This is different. Okay. All right. So my period is 2 pi divided by 4 over 3. Invert and multiply. 2 pi over 1 times 3 over 4 is 6 pi over 4, which is 3 pi over 2. That's my period. What is my phase shift? So the cosine of 4 over 3 pi, or 4 over 3 times the quantity x minus something. Okay, so if I call this number h, 4 over 3 times h is equal to pi over 4. So we invert and multiply. H is 3 pi over 16. Oh, this is going to be nasty. So my phase shift is 3 pi over 16. No fun. So we're moving to the right. 3 pi over 16. Okay. So I draw my negative 2 pi to pi, or to 2 pi. And I'm going to put negative pi there. And I'm going to put pi there. So I need to shift 3/16 pi. So I need to cut this pi into 16 pieces and then go over 3 pieces. And this is a cosine graph, so I'm going to start here. Okay? Yes, because cosine looks like that. Okay? And what's my period? 3 pi over 2. Well, I need to turn that into 16ths. So times it by 8. So 24 pi over 16. Okay? So here I am at 3 pi over 16. If I do a full cycle, will I end before I get to 2 pi? So 2 pi would be 32 pi over 16. So if I started here and I did a full cycle, am I going to have a peak before I get to that? Yes. So somewhere right there. Will I have enough time to do another cycle? So 3 pi over 16 plus 24 pi over 16, this point has an x value of 27 pi over 16. If I tried to do it again, I'm going to run out of room. Okay? So when I backtrack, where is my next peak? How would you calculate that? Well, we're at negative 3 pi over 16, and I need to go back 24 pi over 16. So 3/16 minus 24/16 is negative 21 pi over 16. Is that going to occur before I get to negative 2 pi? Yes, it is. Do I have enough time for another peak? No, because negative 21 over 16 minus 24 over 16 is going to be on the left side of negative 2 pi. So how many peaks are there? This peak did not occur. So there are 1, 2, 3 peaks. That's a hard problem. Okay. Oh, yay, tangents. So tangent graph is totally different from a sine graph. A tangent graph has a period from, well, negative 90 to 90. In radians, it would be negative pi over 2 and pi over 2. And it has vertical asymptotes at those two spots. Okay? And pi over 4 and negative pi over 4 are the 45-degree angles. So if I look at the tangent in quadrant 1, the tangent here, 1 comma 0, is 0 over 1. And then if I look at the 45-degree mark, this is root 2 over 2, and this is root 2 over 2. The tangent at 45 degrees is 1. So, and then here, the tangent is 1 over 0, which is undefined. So the graph looks like this. This point, right, the halfway point between the center and the asymptote is at 1. And on the other side, the halfway point is at negative 1. So the period is pi, and we have asymptotes on both sides of that pi. Okay. Everything else follows the same rules. So I need to pull out pi over 10. So negative 7 tangent of pi over 10 times x minus something. So if I pull a pi over 10, it's going to be x minus 3. You get that? Okay. So my period is no longer 2 pi over a. It's just pi over a. So pi over 1 divided by pi over 10, invert and multiply. Pi's cancel, and my period is 10. So on the graph, I'm going to go left 5 and right 5, and those are my asymptotes. Okay? So my center is here. Halfway in between the center and the asymptote, the value is 1. Halfway between the center and the asymptote, the value is, oh, did I miss that? Yeah, I missed. Because it's a 5, so it should be 2.5. Right there. So right now, this is what my tangent graph looks like. But I need to complete the transformations. So I need to move everything right 3. And that's where this line and this line come from. Okay? And I'm going to make the graph 7 times taller and flip it upside down. So if these are my asymptotes, normally the graph would look like this. So the halfway point is at 1, and the halfway point is at negative 1. But I'm going to flip it upside down and make it 7 times taller. So this halfway point now becomes 7, and this halfway point is going to be negative 7. It's down there. Okay, so it wants you to draw any vertical asymptotes and a point at every x of the graph that occurs on a point at every x-intercept. Okay, so it wants you to graph this line and this line and that, and any point with a coordinate of 7 or negative 7. Oh, so there's another intercept there, and then there's going to be a negative 7 down there, a positive 7 here, and a negative 7 down there, and then we run out of room. Okay. Let me do another one. Okay. So let's write this down. 4 tangent 4 tangent of pi over 8 times x plus 2. And then I can do the whole graph. Okay. So my period is pi divided by pi over 8, and that just turns into the number 8. So from -4 to 4 is my graph, and then halfway will be 1, and halfway will be -1. So right now my graph looks like that. Okay, but this is telling me to shift to the left 2. So I get this intercept and this intercept. And if I count 8 this way, I run out of room. But if I count 8 that way, I need to put another intercept or another vertical asymptote. Okay. And then, so my x-intercepts will be halfway in between my asymptotes, and that's a distance of 4. So if I count 4 this way, I need to put that point as well. So I have 1, 2, 3 x-intercepts. And then normally I would go halfway in between there and go up 1, and halfway in between and go down 1. But this is 4 times taller than normal. So this is going to jump up to here, which means we have a point there and a point there. And then that's going to jump down to there, which means we also have a point there. Okay, that's test 1. Good luck. If you need help, come and see me.